Hello, dear students. So this is our next that series of lectures that I'm going to discuss about these complex analysis. And if you remember that in previous topics we have talked about that these Lorentz or these Taylor series expansion, that was a kind of application of that Cauchy integral formula. And जो हमारा आज का topic है, that's we need to discuss about what is singularity and the types of similarity. And I will, because our main focus, तो जो हमारा focus ज़्यादा रहता है, where we mainly discuss the problems related to those topics, right? So where I'm not going to give you the full proof of these functions, or going to discuss these functions. So I will, our main focus, जो हमारा focus रहता है, तो हम mainly problems पे focus करते हैं, right? Now, so first is singularity. So from the basic, because if you remember that today's we have discussed that what is singularity or what is called a singular point. Suppose we have some function which is not defined at some point z equal to a, right? So then that point is called a singular point, or we can say that that function has singularity at that point. Suppose we have this z equal to z0, so we can say that this is called a singular point. तो इस z0 को हम कह सकते हैं सिंगुलर पॉइंट अगर इसकी इफ इफ द फंक्शन, अगर हमारी जो एनालिटिक फंक्शन होगी, इट सीजेस इट्स एनालिटिसिटी एट z इक्वल टू z0. तो दैट मीन्स, तो इस पॉइंट पे इसकी एनालिटिसिटी खत्म होती है. सो दैट मीन्स एट दिस पॉइंट z इक्वल टू z0 our function is not analytic, right? Or analytic, so if you remember that you just check my previous these videos on these complex analysis, तो ये क्लियर होता है वहां से जो हमारा z इक्वल टू z0, हम कह रहे हैं कि अगर हमारे पास फंक्शन एनालिटिक नहीं होगी तो उस पॉइंट पे हमारी फंक्शन डिफरेंशिएबल नहीं होती है, राइट? तो दैट मीन्स हम कह सकते हैं कि जो सिंगुलैरिटी होती है, अगर किसी पॉइंट की हम कहते हैं कि इसकी सिंगुलैरिटी एग्जिस्ट्स एट सम z इक्वल टू z0 और सम z इक्वल टू a, तो दैट पॉइंट इज बेसिकली कॉल्ड अ सिंगुलर पॉइंट. और वी कैन से दैट जो हमारी फंक्शन है एनालिटिक फंक्शन एफ, so it loses it is, so it is not analytic at z equal to z0, or we can say that the function will not be differentiable at z equal to z0, right? So this is the simple definition. So you can find this definition in every textbook. So I so I consulted that this Arafkin and that grazing book. So we have these two mathematical reference books. So you can study those books and you can find this definition everywhere in each book, right? Now this was, तो हम singularity कैसे define करते हैं. And second topic is, so there are some types of these singularity. So we can have this isolated singularity, we can have removable singularity, we can have non-isolated singularity also, right? So first is that अगर हम, for example, if we talk about this Taylor series expansion, right? Sorry, if you talk about the Lorentz series expansion, so that means if our Lorentz series, that's fz equal to, right? तो Lorentz series हम ऐसे लिखते हैं. And if this series, जो हमारी लॉरेंट सीरीज है, if it contains infinite number of points, तो क्योंकि जो लॉरेंट सीरीज है, I have discussed this topic in my this during that class. तो जो हमारा सेकंड पार्ट इसका होता है, इसको हम प्रिंसिपल कहते हैं, प्रिंसिपल पार्ट ऑफ दिस एनालिटिक फंक्शन. And if this principal part, if it contains that infinite number of these terms, so if the number of terms are infinite, right? So then this point z equal to z0, because so this point is our singular point. So this point z equal to z0 is called, it is called isolated singularity, right? So that's called isolated singularity. So और इसको हम ऐसे भी डिफाइन कर सकते हैं कि फॉर एग्जांपल अगर हमारे पास कोई पॉइंट है, like we have some singular points are equal to z0 while our function is not analytic, or while the function loses its analyticity, right? तो हम कह सकते हैं कि अगर हम देखेंगे, if we see in the neighborhood of that point, suppose we have some point, so our function is not analytic at z equal to z0, तो अगर हम इसके neighborhood में देखेंगे, if we see in the neighborhood of that z0, suppose we have some circle here, right, and this is the center of that circle, suppose, right? तो अगर हम इसके neighborhood में देखेंगे, in the neighborhood of that z0, if there is no other singularity exists for this function f, right? तो अगर कोई और कोई सिंगुलैरिटी नहीं होगी इन द neighborhood of that z0, तो उस सिंगुलैरिटी को हम कह सकते हैं इट इज आइसोलेटेड सिंगुलैरिटी, राइट? सो दिस इज द कंडीशन जब हम पहले कहते हैं कि अगर हमारे पास नंबर ऑफ टर्म्स आर इनफाइनाइट। सेकंड, अगर हमारे पास इफ द नंबर ऑफ टर्म्स आर फाइनाइट, तो जब हमारे पास नंबर ऑफ टर्म्स फाइनाइट बनते हैं तो उस टाइम पे जो z इक्वल टू z0 ये हमें देता है, दैट इज बेसिकली कॉल्ड पोल ऑफ दैट फंक्शन एप्सिलॉन, right? And it depends upon the value of that n. So n का value क्या होगा? Either n can be equal to 1, n can be equal to 2. So you can have higher orders. So that means अगर आपको पोल निकालना होगा, if we have some analytic function, if you write that Lorentz series expansion for some analytic function, and if the number of terms are finite, so in that case you can find the pole of that function and also the order, right? So order means जो highest series का power होगा, right? So that means you can calculate the pole as well as the order for those these functions which are where the number of terms will be finite, right? But in case जब the number of terms infinite होगी, तो उस टाइम पे जो हमारी singularity exist होती है at z equal to z0, so that is called an isolated singularity. Or you can say that अगर हमारे पास कोई singular point है z equal to z0, then you can see in the neighborhood of that point, so there is no other singularity of that f of z. तो उस पॉइंट को हम कह सकते हैं कि ये हमारी आइसोलेटेड सिंगुलैरिटी है। एंड सिमिलरली वन मोर दिस concept is that is removable singularity. So that means so you can also remove the singularity of the function, like if we have this sin z by z, right? तो sin z by z हम इस ये सिंगुलैरिटी रिमूव कर सकते हैं, right? So that means that singularity which we can remove, because if you put that z equal to 0, so you can, when you expand this, so we have discussed this in our this during class, तो ये हमारी तो जो सिंगुलैरिटी हम रिमूव कर सकते हैं, so that singularity is called a removable singularity. And the last one is that's called a non-isolated singularity. So non-isolated singularity, before discussing that non-isolated singularity, you should know about what is the limit point of poles. तो लिमिट पॉइंट ऑफ पोल्स हम कहते हैं कि कोई पॉइंट जो इसका लिमिट होगा, राइट? सपोज वी हैव सम लिमिट पॉइंट ऑफ दिस फंक्शन, so suppose we have that z equal to some a, so this a is the limit point of this pole, right? So that means number of terms will be finite in that case, because when we talk about जब हम poles की बात कर रहे हैं, so that means the number of terms in that Lorentz series are finite in number, right? And if we say that z equal to a, it is the limit point of the pole, तो लिमिट पॉइंट ऑफ द पोल हम तब कहेंगे कि if z equal to a is the singularity of that this analytic function, and in the neighborhood of a there may be some more poles of that function, तो इसके और poles भी हो सकते हैं. So if there are more poles of this analytic function fz, so we can say that, so we have more than, so we can say that z equal to a is the singularity of the function, but it cannot be the pole, right? Because pole जो होता है, it is for isolated, so that so pole उनका होता है जिसमें singularity isolate होती है. But यहाँ पे मैंने कहा कि अगर हमारे पास कोई singular point होगा, but in the neighborhood of that अगर बहुत सारे poles होंगे, so that means हमारे पास more than one singularity है. We have more than one singularity in that analytic function. When we have more than one singularity, so we can say that z equal to a will be the singularity of that analytic function, but it is not the pole, right? So because pole has isolated singularity, so it's more than one, so that means singularity can be a pole, but pole can never be a singularity, right? So every pole cannot be a, sorry, every pole can be a singular, this every pole can be a singularity of that analytic function, but every singularity cannot be a pole, because यहाँ पे अगर हम कहेंगे कि the neighborhood we have many poles, so that means इसमें एक से ज़्यादा more than one singularity exists. So singularity will be more than one, but poles will be isolated. So poles we have this isolated singularity in that case. So that means this. So you can say that these poles lead us to singularity, but तो दैट मीन जो पोल होता है वो सिंगुलैरिटी होती है अगर हम लॉन्टे सीरीज की बात करेंगे, but every that singularity cannot be the pole because poles are isolated, right? So these are some of these definitions that I discuss here, that is this isolated essential singularity, removable singularity, or non-isolated singularity, or you can say that simply essential singularity, right? इसको हम essential singularity भी कहते हैं, right? Now, I will give some examples because in my this during my class we have done some one or two problems on these to how to calculate this singularity, what the nature of the singularity. So I'll give one more example. If we have so we need to find that. So we need to find the nature of the singularity of chord Z. तो हमें देखना है कि इसका जो सिंगुलैरिटी यहाँ पे होगी ये कौन किस टाइप की सिंगुलैरिटी होगी, either it is isolated singularity or it is removable singularity or it can be non-isolated this non-isolated singularity जिसको हम simply essential singularity भी कहते हैं, तो जिसको हम मतलब we can have more than one that singular point of singularity, अगर हमारे पास एक singular point हो so there can be more than that, more than one these singular points or more than one singularity, right? तो जिसको हम नॉन आइसोलेटेड सिंगुलैरिटी कहते हैं, राइट? नाउ इफ यू वांट टू सी, तो यहाँ पे हमें देखना कि वी नीड टू फाइंड द नेचर ऑफ दैट सिंगुलैरिटी एट z इक्वल टू a and z इक्वल टू infinity. Okay, so let us write that. If you write the poles of this f of z, because we need to find, so we can write the poles for this, poles of this f of z. So f of z is, okay, let me write this as, because okay, so we write that let our function f of z is, okay, so what will be the poles of this f of z? So if you write the poles for this, so that is equal to, so you can write that, so you can write that cos of pi z, so this is pi here, cos of pi z. तो अगर मुझे इसका पोल निकालना होगा, so that means our denominator should be equal to 0, right? Because पोल निकालने के लिए we basically पोल हम निकालते हैं for the principal part of the Laurentide series, because we have the two terms in the Laurentide series. Second part of that which contains the negative powers of that z, जिसमें negative powers of z होंगे तो हमें principal part और वहां से भी हमें पोल मिलते हैं, right? So that's a kind of similarity. तो अगर मुझे इसका पोल निकालना होगा, so if you want to calculate this pole of f of z, so that means this denominator should be equal to 0. So that means I can write that equal to 0. Okay, so that means equal to 0, right? So either this is equal to 0 or that's equal to 0, right? So from here you can write that the pi z will be equal to, because if you put that n equal to 1, so that means sine of pi that's equal to 0, or if you put that sine n equal to 2 pi, 3 pi, 4 pi, so that and if you take different values of n, so this will be equal to 0, or you can write sine pi z will be equal to n pi, or z will be equal to, right? तो पहले हमें देखना है कि we need to see, so if you have a look on this, तो अगर हम यहाँ पे देखेंगे तो हमें दो पॉइंट्स के लिए यहाँ पे देखना है कि नेचर क्या होगा सिंगुलैरिटी का, राइट? तो तो पहला पॉइंट है z इक्वल टू ए और यू टेक फर्स्ट z इक्वल टू इन्फिनिटी। अगर हम z इक्वल टू इन्फिनिटी यहाँ पे लेंगे इन दिस केस, तो अगर हम z इक्वल टू इन्फिनिटी लेंगे, so that means n will be infinite here. So that means if you put z equal to infinity, n will be infinity, right? So that means जो हमारे z equal to infinity, it is a limit point of the pole, right? So there can be more than one that poles near that z equal to infinity, right? So that means this z equal to infinity will be here. It is a limit point of the pole, right? And so you can say that then z equal to infinity is तो उसको हम कह सकते हैं नॉन आइसोलेटेड एसेंशियल सिंगुलैरिटी और एसेंशियल सिंगुलैरिटी सिंपली, वो भी कह सकते हैं, और यू कैन से दैट नॉन आइसोलेटेड सिंगुलैरिटी और एसेंशियल सिंगुलैरिटी। नाउ सो दिस वाज फर्स्ट पॉइंट दैट हमें देखना क्या था कि इफ यू पुट दैट z इक्वल टू इंफिनिटी, सो व्हाट काइंड ऑफ सिंगुलैरिटी इट हैज, राइट? सो सेकंड केस इज इफ यू पुट z इक्वल टू a, सो दैट बेसिकली गिव्स अस दिस थिंग। तो अगर हम यहाँ पे z इक्वल टू a लेंगे, तो z माइनस a स्क्वायर equal to 0, right? Or z will be equal to, right? Because so it will not be a single pole because we have this pole of order 2 here, so that means it will be double pole here, right? Because it is power 2, so अगर यहाँ पे power 1 होता है, then it will be a single pole of z equal to a, but here it is power is 2, so you can have z equal to a and a, right? So that means z equal to a is a double pole, right? So that means z equal to a is a double. And similarly, if you talk about this, if we have one more example, suppose that tan of, तो अब हमें देखना कि if we have the tangent function tan of 1 by z at z equal to 0, so we need to find the nature of the singularity, right? So I can rewrite this term as, so that means, okay. So in order to find the nature of the singularity, you can find the poles of this f of z, right? So poles of this f of z, so that will be equal to, or okay. So that means here n equal to, okay. So that means यहाँ पे हमें देखना है कि at z equal to 0, because we can expand कि अगर हम लिखेंगे यहाँ पे that if you put that n equal to 1, so you will get that 2 pi plus minus pi by 2, right? So 2 pi plus minus pi by 2 is, that is 3 pi by 2, or this will be 2 to the 4, 5 pi by 2, 3 pi by 2 or 5 pi by 2, right? So in all the cases you will get that cos of this will be equal to 0. तो अब हमें देखना है कि we need to see the nature of this singularity at z equal to 0. So that means if you put z equal to 0 here, so I can write this as, so that means at z equal to 0, so as we know that 1 by z equal to, that's equal to 12 plus 1, So that means here, if you put that z equal to 0, so this becomes infinite here. So that so this z equal to infinity is basically the limit of pole of this f of z, right? So that means this is the limit point of this, right? And so when it's a limit point of this, so that means this f of z, so it has that non-isolated essential singularity, right? So that means because here z equal to 0 is the limit point of the pole, right? And so we can say that uh, therefore z equal to 0 is, so that's non-isolated essential singularity, right? And similarly, you can take some many more functions, like if we have this sign of that 1 upon 1 minus z, right? So if I have this kind of function, so you can also see the nature of the singularity, right? And so you can find many more problems, so where you can find the nature of the singularity. So hopefully in our coming lecture we will discuss some. This is basically the extension of that Cauchy this integral formula. So that's basically how to calculate the residues and many more problems on this also, right? Thank you.